3I Atlas is no ordinary comet, a single streak of light cutting across the sky in a way that feels unnatural. From the moment it appeared, astronomers knew it was different. Its orbit will carry it past the Sun, near Earth, and then out of the solar system forever. And NASA, with no time to prepare, is betting everything on a worn-out spacecraft, Juno. One burn, one shot, miss, and 3I Atlas vanishes into the dark forever. And the first of those mysteries begins with something deceptively simple: light itself. From its first detection, 3I Atlas challenged expectations. Its nucleus may span 15 to 20 kilometers, already larger than most interstellar comets, yet its brightness spikes far beyond what size alone suggests. The light curve flickers unpredictably, almost as though its surface is reflecting more sunlight than it should. Some researchers even floated the unsettling phrase, unnatural efficiency. To be clear, no one thinks it's glowing on its own. Instead, the suspicion is volatile jets, strange ices, or reflective dust veils, bouncing sunlight in ways that defy current models. Still, the mismatch lingers. Astronomers remember Oumuamua, whose light curve defied explanation, and Hale-Bopp, whose brightness stunned the world in the 1990s. 3I Atlas feels like a fusion of both enigmas: big, bright, and deceptive. This brightness matters. Every estimate of its mass, density, or spin depends on light. If the light misleads, so do the numbers. That means 3I Atlas may be heavier, faster rotating, or more fragile than we assume. And fragile bodies can shatter without warning, turning one object into 1,000 fragments. 3I Atlas isn't meandering, it's threatening cosmic gates with uncanny precision. Its hyperbolic orbit cuts close to the Sun, loops near Earth, and swings past Jupiter before vanishing forever into interstellar space. By pure luck, or perhaps something else, it seems to perform what theorists call a reverse Oberth maneuver, using the Sun's pull to maximize speed. It's a trick spacecraft use: burn fuel at closest approach to a planet or star, and the gravity well amplifies the boost. For 3I Atlas to mirror such precision naturally is startling. The odds of this exact sequence, with planets aligned so cleanly, are astronomically low. What's more is that the orbit is hypersensitive. Simulations show that even a nudge from Jupiter's gravity or a pull of gas from the comet's surface could have derailed the alignment. Yet 3I Atlas holds steady, as though tuned for efficiency. Its eccentricity, greater than 1, confirms it will never return, adding urgency to every fleeting chance to study it. Astronomers caution, coincidences happen, and dynamics are messy. Still, the elegance of this path makes some uneasy. Is it pure celestial luck, or something guided? Even if natural, the orbit imposes brutal deadlines. Observation windows narrow to mere days, and the chance for a spacecraft intercept shrinks to minutes. And that's why NASA is trying something different, turning an old Jupiter orbiter into an interstellar hunter. Juno wasn't built for this chase. Launched in 2011, it spent years mapping Jupiter's storms, magnetosphere, and gravity. Its solar panels, once pristine, are now battered by radiation. Its instruments, they've endured temperatures they were never designed for. Fuel reserves are thin, yet Juno has the one asset we can't fabricate quickly: position. From Jupiter's neighborhood, a small course correction could bend Juno's trajectory toward 3I Atlas. But the gamble is steep. Engineers must coax long idle thrusters back to life, rewriting navigation software for a target moving 60 kilometers per second. The timing window is measured in hours. If Juno misses its burn, the opportunity evaporates. Even success brings challenges. Juno's cameras and spectrometers weren't designed for flybys at such speed. At closest approach, 3I Atlas will streak across its sensors faster than any object Juno has ever tracked. Data may blur, instruments may saturate, and power may fail as solar energy dwindles with distance. Still, NASA is willing to risk it, only because the payoff could be revolutionary. High-resolution images of an interstellar body, spectra revealing exotic ices, even confirmation of whether its brightness hides something unnatural. But the gamble isn't just about science, it's also a rehearsal for something far more urgent: planetary defense. In 2022, NASA's DART mission deliberately slammed into an asteroid, proving for the first time that humanity could alter the path of a cosmic body. That was Planetary Defense 1.0, which took years of planning, one carefully chosen target, and a single controlled strike. 3i Atlas represents the next phase, the unplanned crisis. Can we pivot existing assets quickly, without decades of preparation? Juno's retasking, it's more than a scientific gamble, it's a stress test for planetary defense agility. Real threats won't send invitations, they'll arrive suddenly, discovered late, with orbits we barely understand. In fact, several near-Earth asteroids in recent years, they were only spotted days before buzzing past, a reminder that warning time can be brutally short. Across the globe, others are watching. Europe is building its Hera mission to dissect DART's results. International coalitions are quietly drafting rapid response protocols for surprise objects. If Juno succeeds, it proves we can improvise. If it fails, the message is just as clear: Earth isn't ready yet. Yet, 3i Atlas doesn't just test our engineering. It forces us to confront a deeper, stranger question: what if it isn't natural at all? 3 interstellar visitors in under a decade, Oumuamua, Borisov, now 3i Atlas. That's either cosmic coincidence or a hint that such travelers are common, and we're only now able to detect them. But the peculiarities of 3i Atlas, its brightness, its orbit, they've received SETI debates. Traditionally, SETI has focused on listening for radio signals, but what if technosignatures aren't broadcasts? What if they're objects, silent, passing through, a reflective sail, a probe, or even debris from civilizations long gone? 3i Atlas might not be that, but its defiance of models keeps the door open. Some scientists now speak of cosmic archaeology, where each anomaly could be a shard of a broader galactic story. If interstellar objects arrive this often, perhaps the universe is littered with the ruins of distant systems, and maybe even the handiwork of intelligence. That line of thought feeds directly into the Drake equation. If civilizations are plentiful, their artifacts should be too. Philosophically, it also strikes at the Fermi paradox. If life is common, where is everyone? Maybe they're in artifacts like this, subtle enough to escape notice until we look closer. For now, scientists stress caution. Extraordinary claims require extraordinary evidence, but in the gray zone between natural and artificial, 3i Atlas sits like a riddle we can't yet solve. And that gray zone, it's exactly why the entire world is scrambling to study it before it disappears forever. Telescope time is gold. Every observatory like Hubble, Webb, Keck, Gemini has its own lineup of projects booked years ahead. 3i Atlas has upended those schedules. Emergency requests flood committees. Some astronomers pull political strings, while others accuse rivals of hoarding. What should be pure science has turned into a quiet turf war. And it's not just America. Europe's ESA has slotted time on its very large telescope. China's fast radio dish has scanned for signals just in case. Even Russia has diverted assets, though data sharing remains opaque. The global rush carries undertones of rivalry. Who gets the first clean spectrum, the first high-resolution image? Whoever does controls the narrative, whether 3i Atlas is a frozen rock or something historic. This scramble exposes another truth. We're not prepared for interstellar visitors. Our infrastructure for coordination is clumsy, political, and often mistrustful. 3i Atlas has revealed not just a need for readiness, but for cooperation, because the cosmos doesn't respect borders. Out of this scramble, however, comes inspiration, the drive to build tools ready for the next visitor, not just this one. 3i Atlas may be the last improvisation. Scientists are already sketching designs for standby interceptors, small, fast probes stored on Earth or in orbit, waiting for the next alert. NASA's old CRAF project, once shelved, is being reimagined. ESA's Comet Interceptor, planned for 2029, is a direct response, a spacecraft parked in deep space, ready to pounce on a newly discovered visitor. Some propose fleets of mini-probes, each cheap, each disposable, swarming around interstellar objects to capture every angle. Others dream bigger, nuclear-powered interceptors stationed at lag-range points capable of quick burns towards any inbound mystery. The Rubin Observatory, about to revolutionize sky surveys, will likely find dozens of 3i Atlas-like objects each decade. That means these visitors are not rare, they're routine. And with routine comes responsibility. To be ready, not scrambling. 3i Atlas, it's just the rehearsal, which leaves us with the final question. What does 3i Atlas really mean for humanity's story? 3i Atlas isn't just a comet, it's a mirror, a test of how humans respond when the unknown comes hurtling through our backyard. Its brightness unsettles us, its orbit dazzles us, and its fleeting presence forces us to act faster than we're comfortable with. If Juno succeeds, we'll capture humanity's first close-up look at a massive interstellar body. If it fails, we'll have still learned something profound, that we cannot improvise forever, that readiness must become policy, and either way, 3i Atlas will have shifted our trajectory, scientifically, philosophically, maybe even historically. Because, in the end, this isn't just about a rock, it's about us, and whether we rise to the challenge, whether we build the tools, and whether we dare to double down when the universe deals us mysteries that don't fit the rules. If 3i Atlas's story gripped you, like and subscribe for more journeys to the edge of discovery.